Hello judges and also Bangkit team. We are from HeloTani Capstone team. Before we begin, I would like to thank Bangkit program for giving us the opportunity to embrace our knowledge and challenge our skill in an advanced level. HeloTani brought the theme of empowering smallholder farmers to protect their crops with the smart solutions. So let's meet the crew. Our team consists of 3 MLs, 3 CCs, and 1 MD. And the leader of our team is Arianto Blawamaran, followed by me, myself, Indira Aninda, Timothy Farrell, Fai Christiansyah, Nicholas Priambodo, Rafli Fadila, and last but not least, Muhammad Akbar. Next.
Okay, the next is introduction. HeloTani offer help for smallholder farmer diagnosis crop disease easily and accurately, bridging the tech gap to prevent crop loss and ensure sustainable harvests. Next. According to the Jafar 2024, pest infestation can reduce annual crop productivity by 30 until 33%. Incorrect prediction of this pest can worsen the losses by leading to insufficient preventive measures. Next. Now moving on to our reason. We have two reasons why our team chose this idea. The first one, smallholder farmers, it's crucial for food production. Especially in Indonesia, lack of resources and expertise could lead to crop losses and economic hardship. The second one, bridging the gap between smallholder farmers and technology to empower their growth. And the last reason, by providing treatment, recommendation, and explanation for crop disease. Next.
After doing some research, we found out that there are several apps that focusing on solving this kind of problems related to plant disease and pest detection. However, most of these apps are still limited to certain aspects, such as monitoring, marketing, and general disease detection. None of these are fully comprehensive and easily accessible to smallholder farmers in terms of disease and pest detection. Next.
Now let's move on to the implementation and reasoning. Next. For the machine learning side, we chose EfficientNet with transfer learning as our core model. It's not only accurate but also lightweight, which makes it perfect for mobile devices and low-resource environments. By deploying it with TF Lite, we ensure the app runs smoothly on smartphones, even those with limited processing power. This allows us to bring advanced technology directly to smallholder farmers in a way that's accessible and practical. Next. Our backend is built to handle scalability and efficiency. We're using a Flask API hosted on Google Cloud Run to process images and analyze them. For storing detailed plant disease information, we rely on Firebase, which ensures secure access for users. Google Cloud Storage is used for managing uploaded images efficiently. Together, this setup provides a seamless connection between the app and the TensorFlow model, making the entire process fast and reliable. Next. The app itself is developed in Kotlin to ensure native performance and a smooth experience. We started with Figma mockups to create a clean, user-friendly design that's easy to navigate, even for non-tech-savvy users like farmers. The app focuses on real-time detection and treatment recommendations, so farmers can act immediately when they identify a problem with their crops. It's all about making the technology simple, accessible, and impactful.
Okay. The final result of our project, the HeloTani application project, can be seen at the following points: work and static, machine learning model, plant disease classification model, what's will using TensorFlow, activating good generation on test data to specific performance metric we not provide. Mobile app, the app supported real-time plant disease detection with AI integration. Cloud computing, the classification API is integrated with Google Cloud and image data is stored efficiently using Google Cloud Storage.
Okay, thank you, Afi. I'm gonna continue to explain. Improvement is optimized use of Google Code Service, including compute engine, code run, storage, and enhance application scalability and accessibility. Next. This is a screenshot of our application. Like this, we got opening application, main display, and result scan display. Okay, next.
Okay, the next we will talk about documentation for HeloTani. The documentation is to explain how this project was replicated or studied further by others. And here's our link that we are deployed on GitHub. Okay, in the first one, we will talk about machine learning implementation. We also make multi-class classification model that classifies crop disease that we use TensorFlow library on it. And here's some of image that we got from it. And after that, we got some custom output layers that also with efficient net. And next, and here's also the cloud computing architecture that we have made. The first one, we use some of Google Cloud computing feature that there are VM compute engine for authenticate the users, Cloud Run for the analyze image, Firebase for get disease details, and the last is the cloud storage for store data. Next. And here is our cloud computing repository. For this repository, we can also replicate, or the other people wants to replicate our projects can git clone our projects and follow the step on the README. Next.
Okay, next we already planning 6 months of our further development. We plan to bring HeloTani to Indonesian farmer. For the first month, we plan on launch campaign, which we will focus on build partnership with agricultural cooperative and farmer groups while conducting workshop to introduce the apps. Also, we create the promotional materials and tutorials in local language to ensure accessibility. Our target is 10 plus farming group to establish initial engagement. And for the second month, we're gonna plan on onboarding farmer, which we will distribute the app to local farmers. We're also providing hands-on training through on-site demos and online tutorials. We also set up a support team to address farmers' inquiries and ensure smooth onboarding. And for the third month, we're gonna plan on pilot tests, where we gonna gather user feedback for the app's initial usage. We also focus on engagement, also diagnosis accuracy, and statistification. We also use Insight to debug and release update, ensuring improved app functionality step by step. And for the fourth month, we plan on app refinement, which we will refine the app based on the user feedback. Also, we also enhance disease detection models with collected data, and form collaboration with agricultural extension service to boost our credibility. And for the fifth month, we also expand and marketing, which in this stage, we will expand the app's reach to new region like West Java and Bali and other region. We also launch targeted social media campaign and share success story to increase adoption and trust among farmers. And for the last month, 6 months, we gonna plan on impact measurement, where we will conduct survey to evaluate our app's effectiveness in managing crop disease. We also gonna publish finding to attract funding and partnership. Also, we prepare a strategic plan for nationwide rollout. Next. And here's the budget estimation for that 6 month plan. And also, this is just estimation, so it can change up and down. So the total estimation cost will be 340 million rupiah. Next.
We finally come to an end. To recap, we have presented a solution that addresses this critical issue of crop disease detection. By leveraging AI and machine learning, our app hoping to empower smallholder farmers for a better future. And this is it from us. Thank you for your attention.